Naming ionic compounds is what your guys' test is going to be on tomorrow and the next day. To go over a little bit how to do the names again, on the page that has model 4 on your Pogil, it goes over Ich and Os. Those are for transition metals only because they have multiple charges as possibilities. So for the Ich, this is going to have the greater charge. And for the Os, this is going to have the lesser charge. An example is if you have copper plus 2, oxygen minus 2. So you have copper oxide. And then if you have copper 2 oxide, this has a charge of +1. This has a charge of +2. So the charge of +2 is going to have the greater charge. So this one's going to be cupric oxide. And then this one's going to be cuprose oxide, since it has the lesser of the two charges. So the lesser one is the OUS at the end, and the greater one is going to be the IC, the IC at the end. Another thing when naming ionic compounds, you're going to remember to have the "ide" suffix. So right here we have potassium and we have chlorine, our two elements. We have our two charges at the top, and at the bottom it tells you how many. So we'll have potassium, because the first name does not change of the first element or of your cation. Your anion is going to have the suffix of IDE. So instead of chlorine, your chlorine is going to change into chloride. From chlorine to chloride. So we're going to do some practice on writing the balanced equations. So one example, we're going to do lithium chloride. So for lithium, our symbol is Li. And for chlorine, our symbol is Cl. We know that lithium is in group 1 on the periodic table. So with that, it is going to lose 1 electron and have a +1 charge. Chlorine is a halogen, so it's going to be in group 17, and it wants to gain the 1 electron. So it's going to have a -1 charge. When writing this, these two are already balanced, so you don't need to have any extra lithium or chlorines. So your final answer would be LiCl for lithium chloride. But for a different one, you could do lithium oxide. So you're going to have lithium and oxygen is the oxide. So lithium is Li again with the +1, and your oxygen is going to be -2. So right now you only have 1 +1 and a -2. So the charge on this would be a -1 charge. You want it to balance out and have a neutral charge. So to get that, you have lithium plus oxygen -2. You need 1 more +1. So you're going to add 1 more lithium. So you can have 2 positive lithiums, 2 negative charge on oxygen, and that's going to balance out to a charge of 0. The way you can do that, there are multiple ways you guys can. One way you can is by having it go to the opposite. So with this plus is saying that oxygen only needs 1 oxygen in this instance. Right here, this 2, if you put 2 under lithium, and notice that I don't have a charge written. When you're bringing this number down, it's telling you a quantity. So it's telling you you're going to have 2 lithium and 1 oxygen. It's not telling you -2 or +2. It's just telling you that you have 2 lithium and 1 oxygen. So for your final answer, you can do your math and bring it all down. Your final answer is going to be lithium. There are 2 of them now, 2 lithium, and there's just 1 oxygen. So Li2O. This is called lithium oxide. Okay, we're going to do one more example for you. So if you're given the symbols of Al2S3. You have Al2S3. If you're given this and you're like, okay, I have to figure out what the name is. So you're going to say, okay, this one right here is aluminum. This one right here is sulfur. But it's an anion. So those negative charged ions are going to have that IDE suffix. So this is going to be aluminum sulfide. And this has no transition metals, nothing crazy in it, so it's just aluminum sulfide. Another one could be magnesium chloride. So Mg and Cl. Magnesium is going to be an alkaline earth metal. So for magnesium, +2, chlorine is a halogen, so a -1. How many chlorines would you need? So if you're going to go and do the cross again, this says you need 2 chlorines and just 1 magnesium. So MgCl2. When you're writing the name out for that, you're just going to put, so the first one is just magnesium. And this is an anion, so you're going to have the IDE. So magnesium chloride. Magnesium chloride. And we're going to try one more just with a transition metal, just so we have it. So Ni, which is nickel, S, nickel sulfide. So sulfur we know sulfur's charge. Nickel we don't. Nickel could have one of 2 options. So for sulfur, it's a -2. It's like, okay, if sulfur's -2 and this tells me nickel sulfide, there's no numbers on the bottom. There's no quantities that we need. So the charge on nickel, to balance out the -2, would have to be a +2. So what we have to do next is write out the name. So if we have a +2, this is telling us for transition metals, this is the Roman numerals. So here we're going to put nickel, 2 sulfide. And the 2 is telling us the charge on the nickel. Okay? The Roman numerals are telling us the charge on the nickel, and vice versa. If you were given the Roman numerals, you would know that this is nickel, 2, the positive charge, and sulfide for the S. One last one we're going to do is iron 3 chloride. So you'd say, okay, how do I write iron 3 chloride? I have iron. I have a 3 chloride. I have my Roman numerals again. That's telling me the charge. So if I'm given iron 3 chloride, and it wants me to figure out and write out the equation. So you get the name, you have to write the equation. Iron 3 chloride, chloride's a -1. If you have 3 irons, you have 3 -1s. So that's where you go from 3 down to here. Now you have chlorine, you have 3 -1s. So it'd be 1, 2, 3. And these negatives all add up to -3. And you have your +3. So your final compound is going to be iron 3, chloride, and you're going to have 3 chlorines in your final that you write out. The finals don't have to include the charges, and if it's just one, you don't put a 1 next to the iron. It'll just be iron 3 chloride. Hope this helps, guys.